9 years ago, NASA's Phoenix Mars lander saw something magical. It was the middle of the night, and it was snowing on Mars. At the time, mission scientists believed that this snow acted a lot like it does here on Earth, with individual ice particles drifting down over the course of hours. But thanks to new research published this week in the journal Nature Geoscience, we now know that might not be the only way snow falls on Mars. Instead, just like some storms on Earth, lots of snow might fall pretty much all at the same time, in what's called a microburst. The researchers figured this out using a series of computer simulations that divided chunks of the Martian atmosphere into layers of just a couple hundred meters thick. It might come as a shock to think that a planet as famously dry as Mars even has clouds of water at all. And the Martian atmosphere is definitely pretty dry, but it's also really cold and very thin, which provides the right conditions for what little water Mars does have to form into clouds during the day. Once night falls, though, the temperature drops and some of the ice particles from those clouds start to sink down. This vertical motion creates turbulence both inside and below the cloud, resulting in a process called convection, where cooler air falls toward the planet's surface, taking nearby ice particles with it. Rushing air helps dramatically accelerate the snowfall. Instead of a single flake taking hours to fall, convection pushes it down in just minutes. In most cases, the snow probably vaporizes before it gets to ground level. But sometimes, if the clouds are just a kilometer or two above the ground, the end result might be a blanket of fresh snow on the Martian surface. Maybe not a blanket of snow, but still, it's snow on Mars. The model makes another more ominous prediction. On Earth, microbursts are some of the most common causes for plane crashes, especially during takeoff and landing. So if we ever decide to use drones to study Mars, they could suffer a similar fate. But hey, at least some of the craters they would make would be covered in snow. Snowstorms on Mars weren't the only breakthrough in planetary science announced this week. We also recreated diamond rain with lasers. That's the key result of a new paper out this week in the journal Nature Astronomy, where researchers looked into a weird prediction made about the insides of ice giants like Uranus and Neptune. The interiors of the giant planets have always been extra mysterious because they exist at temperatures and pressures we've only started to be able to create in the lab. For a long time, we've had to rely on theoretical predictions to tell us what the insides of these planets might be like, and some of those predictions can be downright weird, like, for example, a rain of diamonds falling from the sky. Uranus and Neptune both contain a bunch of the compound methane, which is made of a carbon atom and 4 hydrogens. Inside these planets, individual methane atoms start linking together to form chains of carbon-based molecules. Put those chains under enough pressure and, in theory, that carbon might become solid diamond. But that's been hard to test because we're talking about a lot of pressure, about 150 gigapascals. That's roughly the equivalent of stacking 5,000 metric tons on top of a penny, except with tiny molecules. That's pretty hard to do, which is where the lasers come in. To simulate these carbon-based molecular chains, the researchers decided to experiment on a plastic called polystyrene, which also has a bunch of carbon atoms linked together. When you shoot a material like polystyrene with a carefully timed burst of light, you can create a shockwave of pressure that ripples through it. To recreate the environment deep inside Neptune, they used a powerful laser to create not one, but 2 of those shockwaves. On their own, neither would have been strong enough, but when the 2 waves collided for just an instant, the material reached the pressure at which diamonds can form. The researchers also wanted to see this process in action, which involved timing a burst of powerful X-rays to coincide with the shockwave collision. That way they could see what was happening using a technique called X-ray diffraction, which identifies microscopic materials based on how light reflects off their structure. And they saw exactly what they had predicted. The pressure formed nanometer-sized diamonds. In a planet like Neptune, those diamonds could grow thousands of times larger than the biggest we've ever found on Earth, like millions of carats. As they fell through the planet's layers of gas, the giant diamonds would collect in a region surrounding Neptune's core, basically coating it with diamond. Meanwhile, the hydrogen left over from the original methane would float up towards the surface. By separating the heavier carbon from the lighter hydrogen, over time the distribution of mass and even the size of the planet could change, which is important for us to know because a lot of exoplanets seem to be similar to Neptune, and their size is one of the things we can measure. But let's keep our eyes on the real prize here: laser diamonds. It's been a pretty good week for astronomy. Thanks for watching this episode of SciShow Space News, and if all this talk about snow made you want to take a ski trip to Olympus Mons, you can plan your trip while gazing longingly at the SciShow Space ski poster. Get yours at dftba.com/scishow.